Swayam Prabha. Digital India. Educated India.
Okay, so today's so I hope you guys have learned about smart contracts, right? So we are asking you guys to install VirtualBox and then download an appliance which I have put on the internet. So the goal is to what am I doing today? Okay, so basically ensuring that there are nothing wrong with our smart contracts. So what smart contracts do? Do you know what is the intent of it? Can anybody describe the intent? What? Yeah, please.
It's just an application that runs on blockchain.
Yeah, so, but that's what it does. What its intent?
I think the intent could be anything that the programmer wants it to do. It could be a snippet.
Right.
It could be a file sharing service.
Okay. So yeah, very nicely stated that pretty much anything one programmer wanted to do. Okay, but let's suppose I give you X-ray machine or a drone and ask you what is the intent of it. Okay, what is the intent of a drone? Well, whatever programmer wanted to do, but that's not what it is. Okay, there is another underlying goal. Is it's supposed to fly? Okay, it's not supposed to go underwater, right? So there is, when we create this extraordinary concepts, extraordinary I meaning in a very ordinary way, means something special, something unusually defined. Instead of some code we calling it a program, now we are calling it a smart contract. There's an intent here. There's a more than just being a program. Okay, so it is basically trying to relate two different entities or more than two different entities, certain kind of a contractual obligation and enforce them. Okay, basically I give you money, you give me hotel room, things like that. Okay, so they are entities, they will interact, they have certain goals to meet, and to make it happen smoothly, this code sits in the middle between these things. So the contract bit is that. Okay, what is smart here? Why we call it smart? Why it is not dumb contract? What is the word smart doing? As opposed to usual contract, I mean the one, when you rent a house, the thing you sign, is that a dumb contract, or this one is not a dumb contract? And why is it called smart? Like, what is that? Why this keyword? Speak up, say anything. Nothing is wrong here. I'm just, yeah.
Self-aware.
Self-aware. Okay, there's one keyword. Yeah, anything else?
It knows when it has to execute.
When it knows it, I say, okay, so the self-aware, it knows when it's execute but it is executed by human action. You have to say execute. So the smart is that basically the idea is that contracts are generally cryptic and difficult to follow for as normal humans, and only lawyers can deal with it. Now it is something which basically anybody can read online. If you make a contract, it has to be put on blockchain and anybody can see the code, and then what will happen is that and it's some sense introduces fairness. It's more intellectually more refined. When two people are getting into contract, they can clearly see what my obligations are. Okay, and you buy an apartment and the guy will say, if I won't build by the apartment 2025, I will give you your money back. I just checked the website again, the date has shifted to 26. It turns out they can change the date. Okay, so I was in a bad contract. I didn't realize that they give a deadline, but deadline they can change. Okay, so those things won't be possible in that sense. That sense it's smart. Okay, but smartness only exists if the time you're programming the contract is you are smart. Okay, so there can be very silly mistakes, and it's a program. Okay, it's immutable program. Once you commit in the smart on the blockchain, you cannot change it anymore. So you are obligated to follow the contract, and if there's a mistake in it, basically you are doomed. Okay, you doomed with, I mean, there is some way you can design your contract in a way, you can pull back from your commitments, but then you have to put that intelligence yourself in it. Okay, so over time, when people are relying, real businesses, large companies start depending on a smart contract. So as normal, your software fails, your Uber Ola doesn't arrive, okay, things like that goes wrong in your life, your phone doesn't work, okay, Beam doesn't work, okay. The same thing happens with the smart contract. Sometimes they just don't work, okay, because at the time when you're developing the software, the guy did not think enough, and they made a mistake. So this is one example which I am projecting for last 10 minutes, is that this bug in the software, and this caused a company to lose 31 million. And the bug was pretty simple, okay. Basically what bug was that if you have one type of coin and you want to trade with another type of coin, so you basically propose a price, and some guy buys it, okay. And what happens is you basically, and that becomes the next, the price value of the next round, whoever is want to buy and sell. It's like for them to take a reference from. So one guy realized it is not checking, okay. This contract was not checking that that you can buy and sell the same thing. So you say orange, I'm selling the orange and I'm buying the orange, and I'm selling it and buying it to myself, and I keep doing it again and again, and keep the prices pumping it up, okay. And what this guy did, he had some sort of coins, pump the prices up, and using that particular coin he buys everything else, okay, whatever in the contract was there. And yeah, so they lost 31 million. Luckily they only had 31 million in that contract, okay. Okay, so how can we avoid such mistakes, okay? How can we find such mistakes, okay? So before going to specifically to the smart contracts, okay, I just wanted to spend some time thinking about why systems fail, okay, what goes wrong, and what do we need to do, okay, just fundamentals of thinking about systems, okay, and why we are laden with the broken software, okay, right. So why systems fail, basically that's the question we are asking, okay. Okay, so before asking this question, let's go back in time, okay. So all the cartoons you see, I have not drawn them, they are downloaded from the internet, so I have cited most of the place where I downloaded from. Okay, so we go back in time when we didn't have computers. So we get rid of computers, well, we don't have problems, right? We don't have bugs. So but then you are in a stone age, and then basically two guys are sitting, well, life is simple, like something is not right. Our air is clean, water is clean, okay, we plenty of exercise, we eat organic food, but nobody lives beyond 30. Okay, so this is also not ideal situation, okay. Then progress happens, you develop a lot of technology. Now we dependent on so much on technology, and sometimes we expect technology too much. Like think about when GPS, which tells you where are you in a given party, like yesterday, okay. How much technology goes into just find you, okay. There's a satellite in the air, okay, and you're expecting it to connect to you, talk to your phone. Imagine, like, guess how amazing that thing is, okay, and you want it to be instant. I mean, so this is amazing amount of complexity underneath when they locate you in a space, okay, right, okay. So progress brought complexity, which is often hidden in our society. It's like it's so much hidden that sometimes we don't fail to appreciate. So this is a nice cartoon I found somewhere. So the Superman is trying to save a lady from a criminal, and the criminal says, well, I'm not born thief, I'm doing this because I am poor and I basically I need to feed my family, okay. So basically it says that, okay, my employer doesn't pay me enough, so I'm stealing. Okay, fine. So the Superman says, oh, I'm going to punch the employer. Okay. So employer says, no, because economic policies are so complicated, because I'm not able to pay my employees good enough. That's why he blames the politician. Says, okay, it's a politician's fault. Okay. Then this guy goes to punch politician. Well, say, well, I do the right thing if economists tell me what to do. They usually tell you 50 things and all contradictory. And at the end, I do the coin toss, and whatever discussion in the air, I just do that thing. Okay, then he says, okay, I'm going to punch the economists. Okay, they are wrong. So says, oh, well, things is too complicated. Okay, we can't really tell you. Math is just not advanced enough, and we are often guessing, making with lots of assumptions, and then come up with suggestions, and often they don't work. So he blames mathematics. Okay, and then our Superman is very sad that he doesn't know who to punch. Okay, so this is complexity is real problem. Okay, real problem is that sort of elephant in the room. Okay, and things are really complex. Okay, and this complexity basically leads to failure of all the systems. Okay, we live in a society. We're using a computer. We're using social media. We have our bodies, which fails often. Cancer is a big problem, and those are failures of a complex systems. Okay, so this needs to be appreciated in some sense that this is not you cannot have system which will not have bugs. I mean, this is just impossible dream. What you can do, you can minimize it by just thinking about it, working towards to minimize it. Okay, so the question comes that how can we build a bug-free system? Like system should work all the time, most of the time. Okay, and that's my area of research called verification of software systems. Okay, so basically we are trying to see how can we, as soon as software gets developed, immediately it gets checked, and we know that there is no bug. And initially I asked the question intent, right? And the intent is also match the implementation. Okay, and I will come to the intent. Actually, intent part is also very, very tricky. Okay. So, right. So I had to play a video, and
A final decision to go was taken.
So this was Ariane 5. It is this is in 1998, and before that there is Ariane 4. So this is build a new bigger rocket which can take many satellites together, and it goes to. It was being launched in, I think, somewhere in South America. Okay, there is a European Union has I don't know if it was European Union at the time, but I think French have a land there which they call their French Guinea or something, and then from there they're launching. Okay, and this was a big deal because this rocket could do many more things which the previous versions were not. And after it's blown into pieces. And this was a software bug. Okay.
7 seconds into the launch, the onboard computers decided 501 was 90 degrees off.
So what happened was, okay, so what happened was, it was 1996, sorry, okay. So it is like, now it's 26 years, okay. I've been doing this video for last 10 years, so every year I feel more old, okay. So what happens is that people investigated, it's a software bug, okay. So what investigation, software exception was raised because there's a data conversion from 64-bit floating point to 16-bit. So what happened was they wrote a new software, okay, and they had a new processor and old software, and it did the wrong calculations. Okay, so 64 floating point to 16-bit basically, and to a number which cannot be stored in 16 bits. So basically overflow occurred, and it basically went in a different direction. So it was flying right. Everything was going fine. Actually, everything was fine. This mistake has happened in the part which was monitoring the system. and it thought it is going off course. So there's a software there which as soon as it detects that the rocket is going off course, it blows it up, self-destruct. So self-destruction happened because, because computer thought it is going wrong, but it is what all right, okay? Right. So, so the report goes on and it says something more. So the problem is not in the programmer whom you read the line and then you call the programmer, you wrote this code and fire him. Okay, this is not the report says don't do this. Okay, it is not that particular instruction was wrong. You have to understand this bit. Okay, it was the culture in which this software was developed that was wrong. Okay, now what culture they are talking about? It's about talking about French culture? No. Okay, they are talking about this. This idea that the errors forms a normal forms distribution. So let's suppose you buy a telephone poles. You buy 10,000 telephone poles. There is a very nice probability distribution. Some of them will fall apart within a year. Okay, this will be a nice bell curve. Okay, how long they survive. Okay, but that kind of mathematics, which is called Gaussian distribution based, if you have seen this before, doesn't work with software. Software doesn't have that kind of nice distributions. If software has a one line wrong, it will fail every time. There's no probability here. Sometimes it will work, sometimes it won't work. Okay, and then again the distribution of where the bugs are hidden in a system is also cannot be modeled mathematically in a nice way. Okay, so at least today's mathematics cannot do it. Okay, we can't predict bugs basically. We cannot or in other words, we cannot machine learn bugs. But these kind of statements are getting stale every day. Okay, when there's a chat GPT and things like that, maybe I went wrong within few years. Okay, so but still, I have not seen any system which basically can predict bugs in a large systems. Okay, and if you ask something like chat GPT a very specific question, well, okay, in this server I'm not able to connect to that IP address. What is the problem? It will give you a nonsense answer. It can't do things. Okay. So so basically, not only the main system failed, they always have three computers in aviation. You always have everything's replicated 3 times. So what happens is same code was running on all machines and then they all failed. Okay. So essentially, a misunderstanding of the nature of the system. Okay. Instead of basically you saying, okay, randomly generate the test cases, uniformly generate the test cases, and then we will test on those points. That's not the right thing. Okay, so we need to do better than that, and things have gone better. I mean, so still, this is another crash happened. This Mars lander crashed on Mars. Okay. And it's also story is very similar is that when parachute opened, okay, so it put the rotational force on the rocket on the spacecraft, and it is rotated faster than expected. Okay, so sensors got saturated for some very short time, and it triggered that it thought it has already landed, so it started that post landing sequence immediately, and well, they crashed. Okay. Okay, so this is not it. I mean, the bugs are like too many. Okay, so 2017, this is a major bug in kernel, and there is no dearth of going over list of mistakes, and they're happening all the time. Okay, so there is no so there is no dearth of bugs. Okay. So the thing is, the one important bit to his intent. What do we expect from our system? What do we want? That is the question. Because one thing is for sure, rocket must not explode. Okay. What else we want from rocket? So what do you want from rocket? Put satellite in the orbit. Okay. So that's another. So the thing is, I will get to that satellite in the orbit. Is there anything else you want to rocket not to do or to do? Govern, deviate the task given. Okay, but task given, what is the given task? What is the list of tasks? It's too abstract. Right. Okay. I shouldn't kill anyone. Okay, on the ground. Okay, right. I mean, this recently, you know about this Chinese Long March rocket, and when it launches, it drops huge chunk of metal piece on the ground, and it drops it not very close to the ground, it's very high to the ground. So it falls like thousands of kilometers away, like in another country. Okay, you don't know. Okay, we're going to land. So that should not be happening. Okay, so these are like. So we need to have goals that define the set of desired behavior. Okay, and so the thing is that, as somebody said, it reaches to the orbit, it launches the satellite, so it should not explode in the middle. So these are two different kind of properties. One is called safety, other is called liveness. Like if a car which doesn't move, stay always in the same place, it's a safe car, but it's not a live car, it's not a car. So you need both properties, safety and liveness. Okay, right. So what happens is, if you go to a company and then company manager tells you, okay, write this software. Okay, often you will see, you ask them, what do you want from the software? They are very badly explained to you. They give you some documentation, but it's like some blob of text which barely makes much sense. Okay, right. So at the end, what will they will say? Baat ban, like it should work. Some baat ban jaye. Like basically, they will not be able to list the properties. Okay, they will talk in a very vague terms. Okay, and for example, what do you want me to do? They will say, okay, as no offense, but they will say, given all the tasks must be done. So what task? Give me the list of tasks. They say, बहुत काम बता रहा है, मैं दूसरा programmer लूँ. So people don't want to write down what they want. Okay, it's so amazing if you just go and try to talk to any administrator and talk to anybody who managing and try to argue with them what the system you have developed. It may be a hostel rooms, okay, and ask them and then try to split apart their rules, and then you say no, these two rules contradicts, or this rule implies that which you actually don't want. So they will say, get out of my office. Okay. That's what essentially happens. Okay, and then that's where the mistakes are actually. Okay, so once you don't know what the intent is, how can the system do work well? Okay, how do you expect it to be completely doing well? So this is one thing, human limitation of describing. Okay, what do we want? Okay, so so safety and liveness are often at odds with each other. Okay, so liveness always wants to move. It wants you to go somewhere, do something. And safety wants to play conservative. Okay, and this basically two are like contradictory requirements in some sense in systems. You basically have mistakes. Okay, somebody says, okay, this is a new vendor, he wants to support this new feature in IIT Bombay, give him access. The CC says, computer center will say, no, we don't know this guy, why should we give him access? So one is safe, one to live. And they will argue, can we trust this guy? There's some conclusion will be made. Should we grant access to this particular person or not, right? And these decisions are often made in unprincipled manner often, okay? And that's where difficulty lies. Sometimes you will not be able to decide in a very meaningful manner what should we do here. Okay. So, for example, you want governments to be aggressive, take policies, take decisions, do things. In the same time, don't want you to be taking your things on whim. Okay. So you can easily relate to the government where you need basically a live government, same time safe government. Okay, it works with any system within your body or same thing goes. Okay, so so how do you let's look at few aspects of thinking about developing systems. Okay, how do we develop? Okay, so once we have the goals, let's suppose somebody gives the goals. I told you that you already have a big problem what goals are, but even then, let's suppose somebody told you, no, I want this website which is supposed to do this, okay, and this web application, this app supposed to do this thing. Okay, I should be able to find me a taxi. Okay, that's fine. Okay, so what should I do? What kind of software should I use to develop my software? Okay, so so you choose a programming language. Okay, you choose basically visual code, whatever software you want to use. Okay, so then you want organizational structure. You put some organizational structure in your organization. There's a 10 programmer, there's a manager, there's a CEO, whatever, and then you hire the right people with skills. So all these things will come into play when you want to build this safe and usable software, right? So so you need to think about these things, okay? And these decisions are not very trivial and often lead to disastrous situations. And here's an example, which will basically, until you see an example, you will not appreciate what I'm talking about, okay? So, so this is 2010 paper, okay? So there's some famous economists, okay? They process the past century data, and then they basically come to a conclusion: if you have a country has too much debt, the growth of the country is hampered. Okay, it slows the growth. Okay, so why this paper is so important? In 2008 there was economic crisis, and the growth is not happening. So they were saying, look, government borrows the money and hire people. Okay, this government says build this road. Okay, even though there's no economic reason to do it. Okay, so yeah, so they are opposing this idea. Okay, so they were taken very seriously, and basically austerity was a big deal. Okay, basically saying even people don't have job, government doesn't do anything. Okay, so however the student spotted the problem. Okay, the spreadsheet, first he tries to take their data and try to reproduce the result, couldn't reproduce it. Okay, so then he asked for the data. Okay, so that he took the data directly from them and they still could not produce the result. Then he said, okay, actually give me your code. Okay, so that code was in Excel sheet. Okay, so they gave they provided the Excel sheet, which is making the conclusion. Okay, and what happened was, sorry, this box is in the wrong place. When they were trying to match the growth, and they missed 5 countries in the bottom. You can see that when they were selecting to do some calculation, these countries 1, 2, 3, 4, 5 were not counted, in which one of them is Canada. Actually, Canada is highly indebted and their growth is pretty high, something like that. Okay, so the countries which have actually lot of debt and high growth were ignored. And so the thing is, almost any serious work you're doing, you should not be using Excel in some sense. You should be go in a more programmatic manner, such that you can basically you can actually check your code it's correct or not. Okay, Excel sheet basically huge problem. Okay, so why I'm saying Excel is a bad programming environment? Why? Basically, it's nothing about one specific tool. You can take any tool of software development and criticize some way or another. So here is one example how to think about it. Okay, so it's not like you should tomorrow stop using Excel. No, I'm not saying that, and you will not stop. Okay, you will still be doing the small important things using Excel. Okay, and yeah. Okay, so program is not visible to the user. When you look at the cell, you just see the cells. You don't see what is the code behind it. So this is a big problem, because even very complicated code can be hidden underneath a cell, but you see only the output value. Okay, and that's the big problem. Okay, data and programs are not separated. The logic has to be separately explained to someone. Okay, here is the idea, and here is the data. Okay, and then you feed the data into the system, then it produces an output. This got mixed up in the sense. Okay, And it is maybe very convenient, but it's not a good idea. Okay, and no debugging tool. You cannot really say, oh, I'm getting the wrong number here, but why? Okay, can I trace it back? So there's no effective debugging tool, and hard to monitor changes. I mean, now advent of Google Docs, where people can actually monitor changes, it's possible, but still, people don't use it that effectively. Okay. Yeah. So there are many issues. Yeah. Okay. So let's suppose you choose the right. You choose the right development tool. Okay. Now you need to do analysis of your system. Okay. And that's where I come in. Okay. So this long story I'm telling you is get to me. Okay. So once we have built the system, we need an appropriate analysis method to check that the system satisfies the goals. Okay. Right. So you have the goals. You have developed your system. Now you want to check. Okay. So all behaviors of REN5 software should have been analyzed. You basically put in some sort of simulator and run all possibilities. Okay, and see if any of them goes wrong. So what's wrong with that? Just put a supercomputer and just do that. And the problem is that the software on such machines have more states than the stars in the universe. You cannot explore all behavior, just not possible. Okay, it's just things are so complex. If you want to check every possible behavior your laptop can do, it's just too much, too many. Okay, so this is like well, this is not how the life works. Okay, the life doesn't work like, if you want to know that people behaving living properly, you don't ask them to live every possible ways. You always follow rule of thumb. For example, if you want to know that if no intruder is in the room, you just look at the people. Okay, you're not checking in this chair. There's no human in there. Okay, so there's certain abstract ideas you have in your mind. You check finitely many of those things, and those things passes. Then you say, well, probably I'm right. Okay, so this is what needs to be done. Hello. Okay, so here's the system failure, right? Okay. So yeah. So you more states than stars in the universe, right? So right. Okay. So the problem is that even if some state space is large, it's not a problem. For example, if I say x is greater than or equal to 0, it's a huge number of states you're talking about. It's infinitely many things. If you have 64-bit, it's a huge number. But it's very easy to describe. X is positive. So what happens is describing the set of states in which things can possibly go wrong. It's a very ugly object, ugly in a mathematical sense. There's no closed form to it, no way to describe it. It's just like one of those, probability question you must have seen, where you read the question and you say, how do I write this thing down in a closed form? Okay, so so it's a very ugly beast. Okay, and the traditional mathematics simply doesn't work. So what is the traditional mathematics? What is the traditional mathematics is a differential equation, linear optimization, simulation, importance sampling. Basically, those techniques. What is importance sampling? Basically, you sample the system and as you guide it. If you find errors in some area, you sample more. Okay, and if you don't find much errors, you don't sample. That doesn't really work. Okay, right. Now it's reference is getting older and older, and I have to change the images. Okay, so right. So what do we really need is some combination of these techniques. Basically, importance sampling was an interesting idea. Look for bugs where this is interesting, but not just differential equation. You need a much more clever methods. Okay, you cannot rely on probabilistic differential equations. You need to use some discrete mathematics, which we do in computer science. Okay, enumerate certain possible executions, and from there you derive that maybe everything works together. Okay, so you need to develop new techniques, new methods, which has been happening in the last 15 years. Okay, and so basically whatever you can throw at it. Okay, and the story is not yet settled. It's an ongoing process. Okay, so what is happening recently is that technology is somehow matured. Okay, in last 7-8 years, and large companies like Meta, Google, and Microsoft, they have their own in-house software verification teams. So for example, if you upload an app today to Play Store, it will be checked against certain vulnerabilities. Okay, if you're trying to steal somebody's money or something like that. Okay, and the problem is that it is given a certain time window, like few hours. So there is another software which will analyze your uploaded app, and it has given a certain time window, and it checks few things, and if it passes, then you say, okay, it's all good. And if it doesn't pass, it tells you like this kind of things, this kind of function calls you cannot make. Or it will simply say, well, I did my best, but may still be some mistakes in that. So that is often the case. It is often the case, it makes few checks, but still you can pass. It is not fully exhaustive. Okay? So if you know how it works, you can actually design an app which will be actually malicious and will pass through their system. Okay? It is possible. Okay? But you need to really know how they are checking, what they are checking. Okay? And so this is like force of nature. The system is just complex, so complex that Google can. It's not like Google is doing the bad job. It's just not possible. Okay? So right. So the technology has matured. This technology is being used. For example, another give you example, mission critical system is that Airbus new airplanes. Okay, they are fully verified. So they have went through, argued, write mathematical arguments that why this program is correct, why it flies correctly, and they have been successful. So that sense, it's very successful. There's somewhat success story in there. Okay. So today what we are going to do is, first I will give you some very basics, a small basic of formal math foundation, what we do in verification, then give you mathematical foundation for half an hour, then 1 hour I will play with a software which is a Solidity compiler. Okay, you know Solidity what it is? Right, you saw that. So the Solidity compiler called SolC. Okay, so did you install SolC in your computer or you just doing on the web? Yes. So this time I'm a more old timer. So I have given you a VirtualBox with Solidity compiler installed inside it, and you will be writing some smart contracts and editing them. Okay, right. So and we will be checking few properties here and there. Not too sophisticated because it's just introduction, just to get started. Okay, right. Okay, so what do you do when your intent is a software reliability? Okay, so basically you work on software language design, systemic testing, programming environment, technical education. You want to educate your next generation well, that they can appreciate that they should look for bugs, and nothing is like, should not believe that your code is bug free. Then you do formal verification, which is I do. I mean, okay, I will show you what is formal verification is. And automated synthesis. This is an interesting idea. You tell me, you describe what do you want, and code gets generated on its own. You don't need to write software. You need to say what do you want, and code is automatically generated. Okay, this is a crazy idea. It exists. People are working on it, and you may, like in future, maybe there will be no programmers. So, so only computers will be generating on their own new codes. You just tell them what do you want. Okay, right? So basically, all sorts of things and technologies, social, cultural issues has to come together to make an effectively reliable system. Okay, right? So, like software cannot be developed in a very loose, willy-nilly environment. Okay, and this is what, if you have heard the story of FTX, this is what went wrong. Okay, you cannot do these things in a disorganized fashion. Okay, it has to be very strictly controlled in some sense, and then you make reliable software. Okay, right. So, so what is a verification problem in a nutshell? You have a program, and you have given a property. Okay, sometimes it's called specification. I've been calling it intent. There are many words for it, but I'll Mathematically, it's some sort of statement. Okay, and you can have liveness properties, safety properties, quantitative properties. Quantitative properties means you want probabilistically system to work. Okay, sorry, no, that's probabilistic. Quantitative means how well it is going to work. A train must arrive as soon as possible. Not train must arrive. It should arrive as soon as possible. So these are two different statements. Okay, so all these kind of you have programs and it must be checked against certain properties. Okay. Okay, so what do we do is that the desired property is expressed in some logical formula, some formula, mathematical statement. Basically, you will say at this program point, the value of x should be positive. This kind of mathematical statement. Okay, and you will have a program. Okay, and then you need to somehow prove a mathematical argument. It's actually very much the argument which you have done in mathematics. Okay, so like the kind of question like proving a Pythagoras theorem. The steps you take to prove that very similar steps will take to prove this kind of theorem. Okay, there's no fundamental difference. Okay, like what is a program? Program is a text, is a string. All you want to reason about the string's behavior is this. Okay, so you can write the proofs very much like the way you do prove Pythagoras theorem. Okay, there's nothing new here in that fundamental sense. Okay, but the arguments will be different. How you set up the arguments. Okay. Okay. So the abstraction is the key method to prove that a system P satisfies the property psi. Okay, right? So this is a fundamental. It's a fundamental technique. It's called abstraction. So what P does goes what program is. What fundamentally the program is going from one state to another state. Okay, what does program does? It looks at its current variables, looks at its own logic, and say, okay, now this is how I'm going to change my program variables. Okay, right? So this is called So when we define something called abstract programs, which is go from set of states to set of states, it's an imaginary mathematical object which says if I'm somewhere here. If my program makes one step of execution, where are the possible places it can be? Okay, it's going from instead of one state to another state, it's going from a set of states to another set of states. Another way I say is the first thing is arithmetic. It's amazing. You have a young kids. If you say 3 plus 5, they can tell you. If you tell them x is equal to 3, y is equal to 5, then what is x is equal to y plus y? They will not be able to process it. It is certain age, they hit the maturity and they say, yes, what I mean, I can do symbolic substitution. Symbolic substitution is an idea which occurs to you some point of time. I can do this. And then they understand like symbolic algebra is really powerful and can do a lot of things. Okay? So same thing I am doing. Instead of treating a program as an arithmetic which runs the program, I am talking about symbols like if this is variable x, what are the possible values of x? And when you execute the program, what can possible values? Okay. Right? So, this is called abstract program called P hash. Okay? So, so what I will do, I will define this abstract program, okay, in a way that abstract program has more behaviors than the original programs. Okay? And this correct by construction. Okay, so this is by like you designed it in a way P hash that it always behaves in that way, and this I did this because there is some it is done in a clever way such that the second check becomes easy. You may be wondering why this is possible, but this is the goal. This is the game. Okay, so how to So for example, okay, let's take climate change. Okay, climate change is happening, and lot of bad things happening in the climate. So climate change is the consequence. So climate is changing. We can see the bad things are happening in the climate. We see a lot of human activities happening. We do a lot of things. There is a connection. What explains? Okay. Okay. Do I have a pen or something. Okay, so the climate is a complex object, right? A lot of things are happening, okay? Let's wait. And then human activity is also a complex activity. Like we do a lot of things, okay? You cannot really easily describe it, okay? So like there's a human activity, right? And there's a climate change. And I want to say that human activity implied the climate change. Very hard to check. Like this is a program, and this is the consequence. This is what's happening. How do I connect them? Like I can't, like, because I drove a car today, climate is changing. You cannot really meaningfully say that. That statement makes no sense. You want to prove it, you need, what is the proof technique? We can feel it. This is somehow it is connected. What is the proof technique? Can you know how they argue? Like what is the argument? Human activity is causing climate change.
So they will show that there is something that is caused by human activity, and that they
Right. They will choose a parameter which connects those two. Okay, so that's like concentration of CO2. That's an abstract program. Saying increase concentration of CO2, climate goes bad. So this is my p hash. This is my program. I know if I drive car, CO2 will go up. Okay, this is correct by construction. And this checking, you can easily, like you do mathematical simulations and mathematical model. We can show if you increase CO2 and historical data of Earth. There are various ways to demonstrate. It becomes practical. I'm not saying it's easy. It becomes possible you to make an argument of this connection. This is a feasible work, which is our mathematics can argue. Okay? So this is like easier task. This is correct by construction, therefore it is possible. Now, then you may be asking this question, ye CO2 concentration kahan se aaya? How did you realize it? Like how did you find this argument? Okay? That is human ingenuity. That human has to come up with. Human has to say, this is what is important. Like look at these guys. There's so many parameters you could have looked at. But that's where human comes in. So human has to make a choice what abstract program you're supposed to focus on such that you can prove your property. Okay? Right. So